The problem is change the order of integration in the integral 0 to 1, integral x square to 2 minus x, xy dx dy, and hence evaluate the same. The first step is we are going to change the order of integration. Then the second step, we are going to evaluate this integral by using the idea of evaluation of double integrals in Cartesian coordinates. We know the procedure for changing the order of integration. First, let us see the given order of integration. Before that, let us see the limits. The y limits are y equal to x square, y equal to 2 minus x. These two are y limits. X limits are x equal to 0, x equal to 1. By using the limits, let us find the order of integration. Since the x limits are given in terms of constants, first you have to integrate with respect to y, second you have to integrate with respect to x. Now I am going to change the order of integration. For changing the order of integration, we have to express the limits, x limits in terms of y and y limits in terms of constants. Therefore, after changing the order of integration, first we are going to integrate with respect to x, second we are going to integrate with respect to y. Now first let us start the first step. The first step is we have to draw the limits for the curves y equal to x square, y equal to 2 minus x, x equal to 0, x equal to 1. First let us see y equal to x square. What is this? This is nothing but a parabola. What is the general equation of the parabola? X square is equal to 4ay. This is the general equation of the parabola, which is of the form like this. Similarly, we have to draw the parabola y equal to x square. For that, let us construct the parabola by using some x and y values. When you put x equal to 0, y equal to 0. Therefore, this is a parabola which passes through the origin. When you put x equal to 2, y equal to 4. When you put x equal to minus 2, y equal to also 4. Now, when you consider the second one is y equal to 2 minus x. What is y equal to 2 minus x? Now, when you change it to x to the left hand side, x plus y equal to 2. This is of the form ax plus by equal to 2. This is nothing but a straight line. Let us draw the straight line. By putting x equal to 0, we get y equal to 2. When you put y equal to 0, x equal to 2. Therefore, this is a straight line which passes through 0, 2 and 2, 0. We know the lines x equal to 0 and x equal to 1. Now we are ready to draw all the 4 limits or all the 4 curves or lines. First let us draw the parabola y equal to x square by using these limits. It passes through 0, 0. When x equal to 2, y equal to 4. When x equal to 2, y equal to 4. When x equal to minus 2 also, y equal to 4. Therefore, the parabola is like this. This is the parabola x square equal to y. Now let us draw the line x plus y equal to 2, that is y equal to 2 minus x. This is a straight line which passes through 0, 2 and 2, 0. Therefore, the straight line is of the form, this point is 2, 0 and this point is 0, 2. This is the straight line x plus y is equal to 2. Now what is x equal to 0? x equal to 0 is nothing but the y axis. So this is x equal to 0. Now we have to draw the line x equal to 1. X equal to 1 is a straight line like this. X equal to 1. Now let us check whether x equal to 1 passes through this parabola. When you put x equal to 1, what is the y value? Y value is also equal to 1. Therefore, the straight line x equal to 1 and the parabola intersects at the point 1, 1. Now I am going to check one more concept, that is whether the straight line x equal to 1 passes through the straight line x plus y equal to 2. For that, when you put x equal to 1 here, what is the y value? Y equal to 2 minus 1. Therefore, x equal to 1 passes through the parabola and also passes through the straight line x plus y is equal to 2. Now, I have to identify the region of integration. What is the region of integration? The region of integration is nothing but the region bounded by all the 4 boundaries. Our 4 boundaries are y equal to x square, y equal to 2 minus x equal to 0 and x equal to 1. Therefore, x equal to 0, x equal to 1, y equal to x square and x plus y equal to 2. So this is our region of integration. Let us mark it as O, A, B is the region of integration. The point O is nothing but the origin 0, 0. The point A is nothing but 1, 1. The point B is nothing but 0, 2. What is our next step? You have to draw lines parallel to x-axis in that region and you have to find a point where it changes its character. After that, you have to draw a line parallel to x-axis. If possible, divide the region into 2 or 3 parts. Now let us start by drawing lines parallel to x-axis. The lines up to the point A lie in between the straight line x equal to 0 and the parabola x square is equal to y. After the point A, the parallel lines lie in between x equal to 0 and the straight line x plus y equal to 2. Therefore, A is the point where it changes its character. Draw a line passing through the point A parallel to x-axis. Now divide this region OAB into 2, that is OAC and CAB. What is our next step? We have to change the order of integration in each region. Then you have to add all such integrals. For that, consider an elementary strip PQ in the first region. Consider another elementary strip EF in the second region. The strip PQ in the region OAC. The left end of the strip P lies on the line x equal to 0. We have to change the order of integration. We have to express the y limits as constants and x value as a function of y. Now the left end of the strip lies on the line x equal to 0. From this we can identify the x limit. The lower limit is x equal to 0. The right end of the strip Q lies on the parabola x square is equal to y. Our idea is we have to express x as a function of y. Therefore, from this equation x square is equal to y, we can write x equal to root y. Thus we have obtained the x limits in terms of y. The next step is, in the region we have to find the corresponding y limits. That is, we have to express y as constant limits. For that, let us find the range of the strip in this region. The lowest value of y in this region is y equal to 0 and the highest value of y in this region is y equal to 1. Therefore, in this region OAC, y varies from 0 to 1. Now the given function is nothing but xy. Thus we have changed the order of integration in the region OAC. See, first y limits are given in terms of x and x limits are in terms of constants. Now after changing the order of integration, we have expressed y limits as constants and x as a function of y. Now we have to follow the same procedure for the second region. The second region is CAB. In the second region CAB, consider the strip EF. The left end of the strip lies on the line x equal to 0 and the right end of the strip lies on the straight line x plus y equal to 2. Our aim is we have to express x value in terms of y. Therefore, from that equation we can write x equal to 2 minus of y. This is the corresponding x limit in terms of y. In the same region, that is in the region CAB, we have to find the y limits as constants. That is the range of y in this region. Here the lowest value of y is, y varies from 1 and the highest value of y is, it ends with b. The coordinates of b are nothing but 0, 2. Therefore in this region y varies from 1 to 2. Therefore the corresponding y limits are y equal to 1 to 2. Thus after changing the order of integration, the given integral, integral 0 to 1, integral x square to 2 minus x, xy dx dy becomes, that is the first part, y equal to 0 to 1, x equal to 0 to root y, xy dx dy, plus the second part, second region is CAB. Here y varies from y equal to 1 to 2, x varies from x equal to 0 to x equal to 2 minus y, xy dx dy. Now let us take the first integral as I1 and the second integral as I2. I1 plus I2 gives the solution for this problem. Now we have completed the first part. The first part is we have to change the order of integration. We have changed the order of integration in the two regions and we have added the two integrals. The next step is, the problem is, and hence evaluate the same. Now we have to evaluate this double integral. We can evaluate this double integral by using integration. Let us consider the first integral. The first integral is y equal to 0 to 1, x equal to 0 to root y, xy dx dy. First I am going to integrate with respect to x. After substituting the x limits, the resulting expression can be integrated with respect to y, then use the y limits. So let us start the integration. First I am going to integrate with respect to x, keep the y term arbitrarily as a constant. So integration of x will give you x square by 2, therefore the y term as it is. Therefore after integration this will become x square y by 2 between the limits 0 to root y. Keep the other integral, that is y equal to 0 to 1 dy as it is. Now substitute the, this is nothing but x limit. So substitute the limit only for x. I am going to substitute for x, that is x square. Instead of x I am going to substitute root y. Therefore this will become root y the whole square. Root y the whole square is nothing but simply y. Y into y is y square by 2. Now the lower limit is 0. When you put x equal to 0 here, 0 and anything will gives you 0. Therefore after integrating with respect to x and substituting the limits, the given integral will be of the form y equal to 0 to 1 dy. Now I am going to integrate this. When you integrate this y square with respect to y, this will become y cube by 3. So when you multiply that by 2, that will become y cube by 6 between the limits 0 to 1. Therefore the answer for the first integral is, after substituting the limits, y cube, y value equal to 1. Therefore 1 by 6 minus of 0 by 6, which gives you 1 by 6. Therefore I1 integration answer is 1 by 6. Similarly we have to evaluate the second integral. Let us evaluate the second integral. First let us integrate with respect to x. Y equal to 1 to 2. I am going to integrate with respect to x, keeping y as a constant. Therefore this will become x square by 2. Keep the y as it is between the limits 0 to 2 minus y dy. Now I am going to substitute the limits for x only. So when you substitute the upper limit 2 minus y for this x, this will become 2 minus y the whole square into this y whole divided by 2 minus, I am going to substitute the lower limit for x. This will become 0 into y divided by 2, that will become 0 into dy. So let us take this 1 by 2 as a constant term outside. 1 by 2 into integral y equal to 1 to 2. Let us expand this by using the formula a minus b whole square. The formula is a square plus b square minus 2ab. A square means 4, b square plus y square minus 2ab means minus 2 into y, that will become minus 4y into y dy. Now multiply this with this y and then integrate. Y equal to 1 to 2. When you multiply this will become 4y plus y square into y cube minus 4 into y square into dy. Now I am going to integrate this with respect to y, which is equal to 1 by 2 into, when you integrate this, 4 into y square by 2 plus y power 4 by 4 minus 4 y cube by 3 between the limits 1 to 2. Let us start the limit substitution. First substitute the upper limit. When you substitute the upper limit for this y value, this will become 4 into y square value. Y value is 2, therefore 4 divided by 2 plus y power 4. Y power 4 is nothing but 2 power 4. 2 power 4 is 2 into 2 4. 4 2s are 8. 8 2s are 16. 16 divided by 4 minus of 4 into y cube. Y value equal to 2. Therefore 2 cube. 2 cube is nothing but 2 into 2 into 2, that is 8 divided by 3. I have substituted the upper limit minus the lower limit. The lower limit is 4 into, this is 1 by 2 plus y power 4, that is 1 power 4, which is 1 by 4 minus 4 into y cube, that is 1 by 3. Now I have substituted the upper and lower limits. By simplifying, we can get the full answer. We cancel this with this. Therefore 4 2s are 8. 16 by 4 is nothing but 4 minus of 8 4s are 32 divided by 3. Here you cancel with this minus 2. When you release the bracket, this will become minus 2. Next term is minus 1 by 4. Next term is minus of minus plus 4 by 3. Let us simplify this. 8 plus 4, 12. 12 minus 2, 10. Minus 32 by 3 plus 4 by 3, which gives you minus 28 by 3 minus 1 by 4. To take LCM 12, therefore this will become 120 minus 28 into 4 minus 3. After simplification, this gives you 5 divided by 24. This is nothing but the answer for the second integral. The full answer for the given problem is first integral plus the second integral. First integral answer I1 is equal to, we have obtained as 1 by 6. Second integral answer is 5 by 24. Now again you take LCM 24. So this will become 4 plus 5, which is equal to 9. 9 divided by 24. On simplification, this gives you 3 divided by 8, which is the required answer. Thus we have changed the order of integration in the given integral, and we have evaluated the given integral and obtained the full solution as 3 by 8. Let us see the next problem. This is of the next type. Evaluate integral 0 to 3, integral 1 to square root of 4 minus y. The function is x plus y dx dy by changing the order of integration. By using the limits, first let us identify the given order of integration. Here 1 and square root of 4 minus y are nothing but x limits. X equal to 1, x equal to square root of 4 minus y. Here they have expressed x in terms of y, and the y limits are constants. Y equal to 0, y equal to 3. Y value is expressed as constants. Therefore, what is the given order of integration? First you have to integrate with respect to x. Second you have to integrate with respect to y. I am going to change the order of integration. For changing the order of integration, first I am going to integrate with respect to y. Second I am going to integrate with respect to x. For that we have to change the limits. How we can change the limits? We have to express x values as constant limits and y as a function of x. For changing the order of integration, we have to express the limits as x as constant and y as function of x. Now by using these limits, first let us identify the region of integration. We know the lines x equal to 1, y equal to 0 and y equal to 3. So first let us consider x equal to square root of 4 minus y. What is this? When you square this, this will be of the form x square equal to 4 minus y. This is nothing but a parabola. Let us identify the parabola. When you put x equal to 0, y value equal to 4. When you put x equal to 0, when you change this y to the left hand side, y equal to 4. When you put y equal to 0, x square value equal to 4, x equal to plus or minus 2. When you put y equal to 4 here, x square is equal to 0. When you put y equal to 3, x square is equal to 1, x equal to plus or minus 1. Now let us draw the diagram by using the limits. First draw the line y equal to 0. Y equal to 0 is nothing but our x-axis. Next y equal to 3. Y equal to 3 is a line parallel to the x-axis. Next the line x equal to 1. X equal to 1 is a line parallel to y-axis. Now let us draw the parabola x square is equal to 4 minus y. The parabola intersects the y-axis at 0, 4. Therefore this is 0, 0, 1, 0, 2, 0, 3. Let us take this point as 0, 4. So the parabola passes through this point and x equal to plus or minus 2 means y equal to 0. X equal to plus or minus 2, x equal to plus 2 and x equal to minus 2. Y equal to 0. Therefore 2, 0, minus 2, 0. So the parabola is of this form. Now I am having one doubt whether this parabola passes through this point. So for that, when you put y equal to 3, what is the value? X equal to plus or minus 1 by 3. What is this point? This point is nothing but x equal to 1, y equal to 1 by 3. 1, 3. X equal to 1, y equal to 3. Therefore the point is 1, 3. Therefore the parabola passes through the point 1, 3. And also it also passes through another point minus 1, 3. We are going to find the region of integration that lies only in the first quadrant. Therefore this is the parabola. Now we have to identify the region of integration. What is the region of integration? The region of integration is nothing but the region bounded by all the 4 limits. If you take this region, what is this line? This is nothing but our y-axis. What is the equation of y-axis? X equal to 0. X equal to 0 is not given in our limits. Therefore these two cannot be our region of integration. Therefore let us pass on to the next one. If you take this region, this is bounded by the line x equal to 1, y equal to 0 and the parabola and also with the line y equal to 3. Therefore this is our region of integration. Here consider a strip parallel to y axis. Let us name the strip as PQ. So we are going to change the order of integration. What we are going to do? We have to express x limits as constants. So x limits as constant. Therefore I am going to integrate with respect to x lastly. Y limits as function of x. Therefore first I am going to integrate with respect to y. Then I am going to integrate with respect to x. Now I have to express y value as a function of x and x as constant. Here the region of integration is, let us name it as OAB is a region of integration. What is the next step? You have to find a point where it changes its character. So here you have to draw lines parallel to y axis, because the strip is parallel to y axis. You have to draw lines parallel to y axis. Here all the lines parallel to x axis, y axis lie in between y equal to 0 and the line y equal to 3. Therefore there is no point where it changes its character. Therefore there is no possibility of dividing this region into 2 or 3 parts. Therefore the only region is OAB is the region of integration. Now I am going to change the order of integration by changing the limits. So the lower end of the strip gives the lower limit and the upper end of the strip gives the upper limit. The lower end of the strip lies on the line y equal to 0. Therefore the lower limit is y equal to 0. Upper end of the strip lies on the parabola. What is the name of the parabola? X square equal to 4 minus y. I have to express y value. Therefore y equal to 4 minus of x square. This is the upper limit. Now I am going to find the x limits as constants in that region. What is the range of this strip in this region? It varies from, what is this corresponding point? This point is 1, 0. It varies from 1, 0 to 2, 0. Therefore I can write the x limits as x equal to 1 to 2. X equal to 1 to 2. Therefore after changing the order of integration, the given integral will be of this form. The next step is we have to evaluate this integral. Now I am going to evaluate this integral. First I am going to integrate with respect to y. Then we are going to substitute the y limits. Integral 1 to 2. I am going to integrate with respect to y. Therefore this will become xy plus y on integration with respect to y will become y square by 2 between the limits 0 to 4 minus x square into dx. Integral 1 to 2. Substitute this for y value. Therefore x into, instead of y you substitute 4 minus x square plus y square 4 minus x square the whole square divided by 2 minus the lower limit for y. So when you put y equal to 0, this will become 0 here also. Therefore y limit will become, the lower limit will become 0. Next, integral 1 to 2. Let us expand this. X into 4, 4x minus x cube plus 1 by 2 into, expand this by using the formula a minus b the whole square. A square plus b square minus 2ab into dx. So let us simplify this and integrate with respect to x. Let us divide the second term by 2. This will become 16 by 2 8 plus x power 4 by 2 minus 8x square by 2, that is 4x square. Keep the first bracket as it is, 4x minus of x cube. Now I am going to integrate this with respect to x. Then I am going to substitute the limits 1 to 2. First let us integrate with respect to x. When you integrate 4x with respect to x, that will become x square by 2 minus second term x cube. X cube on integration gives you x power 4 by 4. 8 is a constant. Therefore we are going to integrate integral dx. Integral dx gives you 8x plus x power 4 on integration gives you x power 5 by 5. 5 into 2 10, x power 5 by 10 minus 4 into x cube by 3. Now let us start the limit substitution. The upper limit is 2 and the lower limit is 1. Substitute instead of x as 2, that is 4 into 4 by 2 minus 16 by 4 plus 8 2s are 16 plus 2 power 5 32 by 10 minus 4 into 2 cube by 3 8 by 3 minus the lower limit is, instead of x we are going to substitute x value as 1, that is 4 by 2 minus 1 by 4 plus 8 plus 1 by 10 minus 4 by 3. Simplifying this we get the result as 241 divided by 60. That is the net answer. We have completed two problems. The first problem is integral 0 to 1, integral x square to 2 minus x, xy, dy dx. Here the given order of integration is, first we have to integrate with respect to y, then we have to integrate with respect to x, because x limits are given in terms of constants. If x limits are given in terms of constants, while proceeding in the problem, draw a strip parallel to x axis. That is, if the given problem, if the limits, x limits are in terms of constants, draw a strip parallel to x axis. In the second problem, here y limits are given in terms of constants. Therefore, draw a strip parallel to y axis. So, drawing strips parallel to x axis and y axis depends on the limits. So, I will explain once again. If x limits are constants in the given problem, or in the given order of integration, if you are going to integrate with respect to x secondly, then draw a strip parallel to x axis. If the given, in the given problem, if the y limits are constants, then draw a strip parallel to y axis. So please make a note of it. If x limits are constants, draw a strip parallel to x axis. If y limits are constants, draw a strip parallel to y axis. This is the main idea behind drawing the strips in the region of integration.